Hall effect sensors. They are named after Edwin Hall, who invented this, or he discovered this property quite a few years ago. And the idea is that you have a large metallic plate like this. You connect this to a source. Let's say that you connect it to a current source, so you push current through it. And of course the electrons, they go the opposite way, so the current goes this way, but the electrons, they go the other way around, so I will draw them in blue. The electrons, they will go like this and more or less distribute evenly across the plates here. So you have electrons that will go around like this. They will move across from one side to the other. So far everything is good. And if I were to measure the voltage here, let's say that I connect some connectors here to the plate, and I try to measure the voltage like this. Well, the electrons are evenly distributed, so the net voltage measured from top to bottom there would be 0. Now let's do something different. Let's remove the electrons here. And let's apply a magnetic field. Let's say that I have a magnetic field that goes into the board like this. The symbol here, the cross, is like if you're watching the back side of an arrow. I guess 6 such will do. The point is that there is an even magnetic field across the into the board, through the plate like that. Now if I still have my electron here, I have one electron here, and it's moving, and you have a moving electrical charge in a magnetic field. Well, then the right hand rule comes into play, and you will actually get a force. So you will get a force pushing the electron, in this case, downwards. I'm running out of colors here. Let's use black. So the electron will be pushed downwards here in this case. And therefore, most electrons will actually collect close to the bottom, like this. The electrons will go like this, basically. So there will be a lack of electrons up here, and there will be an overrepresentation of electrons down here. So you will have, due to the lack of electrons on top here, you will actually have a positive electrical charge here. And since you have too many electrons down here, you have a negative electric charge down there. So you will measure a voltage across the voltmeter like that. Now, if the magnetic field changed to the opposite direction, the current flowing in the same direction, but the electrons would now go up and down here, and the polarity of the measured voltage would change. So therefore, the Hall effect sensor is a sensor that detects the change in or detects magnetic fields. So now we have something that can detect magnetic field. Well, when Mr. Hall discovered this property of large electric or a large plate carrying electric currents, it was found to be quite interesting, but quite useless actually at the time, because they weren't able to make instruments that or it wasn't very useful to create such large instruments that that this technology would require. But later, after Mr. Hall, they discovered semiconductors. And by using semiconductors, we can now make Hall effect detectors that are about the size of a quarter of a fingernail. So maybe you've seen them as a part of a bicycle speedometer, where you have a small magnet connected to one of the spikes of the bicycle wheel, and then you have on the fork of the bicycle you will have a sensor, and that would be a Hall effect sensor detecting the magnet as it passes by. So that would be a Hall effect detector. So what they do is they detect a magnetic field or a change in magnetic field. And they can also detect a constant magnetic field. It doesn't have to change at all. So they are very useful, because the other detectors, like the pickup coil and so on, they detect the changing magnetic field. This one can detect a constant magnetic field. So for example here, you have a pressure sensor. If you apply a pressure on this side, this will move the membrane downwards. The magnet comes closer to the Hall effect detector down there, and is detected as a higher voltage in or from the sensor. Here a metallic ball is running, for example, on a pinball machine, and that would manipulate the magnetic field that is around its permanent magnet. And here is a tilt sensor. If I tilt this one, so it's now like this will still drop downwards here, but the whole magnet would be up here, so that would be able to be, that you could use that as a tilt sensor, for example, on board a ship.